Biasing in electronics means establishing predetermined voltages or currents at various points of an electronic circuit for the purpose of establishing proper operating conditions in electronic components. Many electronic devices such as diodes, transistors and vacuum tubes, whose function is processing time-varying, AC, signals also require a steady, DC, current or voltage at their terminals to operate correctly, a bias. The AC signal applied to them is superposed on this DC bias current or voltage. The operating point of a device, also known as bias point, quiescent point, or Q point, is the DC voltage or current at a specified terminal of an active device, a transistor or vacuum tube, with no input signal applied. A bias circuit is a portion of the device's circuit which supplies this steady current or voltage. In electronics, bias usually refers to a fixed DC voltage or current applied to a terminal of an electronic component such as a diode, transistor or vacuum tube in a circuit in which AC signals are also present, in order to establish proper operating conditions for the component. For example, a bias voltage is applied to a transistor in an electronic amplifier to allow the transistor to operate in a particular region of its transconductance curve. For vacuum tubes, a grid bias voltage is often applied to the grid electrodes for the same reason. In magnetic tape recording, the term bias is also used for a high-frequency signal added to the audio signal and applied to the recording head, to improve the quality of the recording on the tape. This is called tape bias. Importance in linear circuits. Linear circuits involving transistors typically require specific DC voltages and currents for correct operation, which can be achieved using a biasing circuit. As an example of the need for careful biasing, consider a transistor amplifier. In linear amplifiers, a small input signal gives larger output signal without any change in shape, low distortion. The input signal causes the output signal to vary up and down about the Q point in a manner strictly proportional to the input. However, because the relationship between input and output for a transistor is not linear across its full operating range, the transistor amplifier only approximates linear operation. For a low distortion, the transistor must be biased so the output signal swing does not drive the transistor into a region of extremely non-linear operation. For a bipolar junction transistor amplifier, this requirement means that the transistor must stay in the active mode, and avoid cutoff or saturation. The same requirement applies to a MOSFET amplifier, although the terminology differs a little. The MOSFET must stay in the active mode, and avoid cutoff or ohmic operation. Bipolar junction transistors. For bipolar junction transistors, the bias point is chosen to keep the transistor operating in the active mode, using a variety of circuit techniques, establishing the Q point DC voltage and current. A small signal is then applied on top of the bias. The Q point is typically near the middle of the DC load line, so as to obtain the maximum available peak-to-peak signal amplitude without distortion due to clipping as the transistor reaches saturation or cutoff. The process of obtaining an appropriate DC collector current at a certain DC collector voltage by setting up the operating point is called biasing.